Okay, 12.1, Part 1. So this is using the fundamental counting principle, and then also finding permutations. So we're going to use the fundamental counting principle to find the number of different combinations of events and how they can occur. And then we're going to use the fundamental counting principle to find the number of permutations of events happening. So two events for the fundamental counting principle state that they can occur if one event can occur in m ways and another event can occur in n ways, then the number of ways that both events can occur is m times n. So in other words, if you flip a coin, that's two different possibilities, and then roll a die, that's six different possibilities. So when you flip a coin and roll a die, if you multiply those two together, you get 12 different combinations. And that should make sense kind of intuitively. You can either have heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, or you can have tails and 1, tails and 2, tails and 3, tails and 4, tails and 5, tails and 6, for a total of 12 different combinations. So we can expand that to any number of events. So if we have 3 or more events, then the fundamental counting principle can still be applied. So if we have m, n, and p for the different ways that things can occur, we just do m times n times p. So now using this, one of the classic examples is ordering a pizza or buying a sandwich or ordering an ice cream from Cold Stone. So we have different choices for different things. So if we're going to buy a sandwich where we have choices of 5 different meats, 4 different cheeses, 3 different dressings, and 8 other toppings, where we can pick 1 meat, 1 cheese, 1 dressing, and 1 other topping, how many different sandwiches can we make with one of each of those selections? So we have 5 different possibilities for meat, 4 different possibilities for cheese, 3 for dressings, and 8 for other toppings. Okay, so I just go through and I work it through. 5 times 4 is 20, times 3 is 60, times 8 is 480. Okay, pretty straightforward. So we can continue this. So if we go to the next slide, go to example 2. So example 2, we're going to continue it now using the fundamental counting principle. So this time we have a town has telephone numbers that begin with 400 or 432 or 437. So that's 2 different prefixes right now. So we're going to have to take that into consideration later on. We need to remember that. So we have 2 different possible prefixes followed by 4 digits. How many different telephone numbers are possible if the last 4 digits cannot be repeated? So if we cannot repeat the digits, that means that there are 10 choices for the first digit, so 0 through 9. Okay. But then only 9 digits remaining for the second digit. Okay, because we've used one of those digits, 0 through 9, so that means that now there are only 9 remaining choices, 8 remaining choices for the third digit, and 7 remaining choices for the last digit, which means that my possible number of telephone numbers is, first of all, we have 2 prefixes times 10 numbers for the first digit, 9 for the second, 8 for the third, and 7 for the fourth. So if you go through and multiply those out, you will get the total number of possible phone numbers, which is 10,080. Okay. Now, the last thing that we're going to talk about for part 1 here is what are called permutations. So this is how things can happen in particular orders. So in this case, we're talking about 26 golfers are in a competition. And how many different ways can 3 of the golfers, Okay, so 3 of the golfers finish first, second, and third. So we're going to take 3 out of the 26 golfers and put them in first, second, and third place. So for first place, any of the 26 golfers can come in first. Okay, so we're going to assume that all of them are equally likely. So we have 26 golfers that can finish first. Then if one of them finishes first, that means that there are only 25 left that can finish second. And then, of course, there's only 24 that can finish third. So the number of ways that the golfers can place first, second, and third is 26 times 25 times 24, which if we do that on a calculator, we get 15,600 different possible ways that the 26 golfer competition can have a first, second, and third place.